Hi class. In this lecture here, what we're going to do is we're going to look at three different trigonometric formulas. We're going to look at what's called double angle formulas, power reducing formulas, and half angle formulas. And what I want to do in these lectures here is I just want to introduce you to the formulas and then just work some very simple examples about, just some application problems of them or applications of the formulas. These formulas will come up later on in your academic career, especially if you move on to take the calculus sequence. And we'll also use these when we talk about solving trigonometric equations in a later video, in a later lecture. Okay, all right, so what we're going to do here, what we're going to work through is we're going to talk about how you use the double angle formulas, how you use the power reducing formulas, and then how you use the half angle formulas. Okay, so first off, what exactly are the double angle formulas? So it works like this. If you have sine of 2 theta, so notice here you have, in all the cases, you have sine 2 theta, cosine 2 theta, tangent of 2 theta. So you have this 2, 2, 2 in them, okay, like that. In all cases, what you can do is you can simplify the formula such that the double angle, 2 times theta, just becomes theta. So the formula, first one we have is sine of 2 theta is equal to 2 times sine of theta, cosine of theta. So notice how it's in terms of theta, not 2 theta anymore. Cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. And tangent of 2 theta is equal to 2 times tangent of theta divided by 1 minus tangent squared theta. Turns out that using the Pythagorean identities, you can also rewrite the cosine of 2 theta the following ways. So cosine of 2 theta, again, can be equal to cosine squared of theta minus sine squared of theta. Or it can be written as cosine of 2 theta is equal to 2 times cosine squared theta and then minus 1. Or you could write cosine of 2 theta is equal to 1 minus 2 sine squared of theta. Doesn't matter. Okay, they're all the same. They're all equivalent to each other. All right, we're going to focus on these formulas here, though. Okay, and so here'll be the first problem we want to do. All right, and we've worked problems like this in a previous lecture, and so we'll set this up, and you'll hopefully remember how you set this up with the right triangle. Okay, so here we go. If sine of theta is equal to 4 over 5, and theta lies in quadrant 2, so theta is a quadrant 2 angle. I want to find the exact value of sine of 2 theta, and then I want to find the exact value of cosine of 2 theta, and then I want to find the exact value of tangent of 2 theta. Okay, so the first thing you're going to need to do, all right, you need to sketch the angle and set up a right triangle. Okay. So it's a quadrant 2 angle. Forgive the little sloppy drawing there to start here. Quadrant 2 angle. All right. So theta is going to be somewhere over here. Okay. So here's theta. Okay. And all I'm going to do is I'm going to drop down a right triangle here. Okay. Like this. All right, so remember what sine is, right? So if you remember your right triangle trig, sine is opposite side over the hypotenuse. So here's theta, so the opposite side of theta has to be 4, and the hypotenuse has to be 5. So hopefully what you can see here is this is going to be a 3, 4, 5 right triangle. But because it's quadrant 2, okay, quadrant 2, our x value here is -3, right? So this is a 3, 4, 5 right triangle. All right, so what you then can see here is you can just figure out the values of sine of theta, cosine of theta, all right, we know is the adjacent side over the hypotenuse. So that's -3 over 5. And tangent of theta, right? Remember your SOHCAHTOA, some old horse caught another horse taking oats away, so it's opposite over adjacent. I don't know if that saying is, it helps me remember. So opposite side is 4, adjacent is -3. So this is -4/3. Okay. So look, sine of 2 theta. So just remember, keep these handy because I'm going to use these on all the next few slides here. Okay. Sine of 2 theta. Well, look, just go back to your formula. What is sine of 2 theta? It's 2 times sine of theta times cosine of theta. Well, look, I don't know what sine of 2 theta is, but I know what sine of theta and cosine of theta is. So this is 2 times 4/5. And then what exactly is cosine of theta? That's minus 3/5. Well, 2 times 4 is 8, times minus 3 is minus 24. 5 times 5 gets me 25. So I've got it. All right, let's take a look at the next one here. And I'm going to be popping back to this slide here for these values too. Okay, so it's the same setup. So what is cosine of 2 theta? Well, look, go back and you can use any one of these formulas and you'll get the same answer. So I'll just use the first one. It's cosine squared of theta minus sine squared of theta. Well, just so we're clear here, that's cosine of theta squared minus sine of theta squared. All right, so look, what was cosine of theta? Cosine of theta was minus 3/5. Minus, and then sine of theta was 4/5. So minus 4/5 squared. So look, this becomes 9 over 25 when you square it. Negative, negative becomes a positive. Minus 16 over 25. So cosine of 2 theta is just minus 7/25. And then look, we also know the value of tangent here, right? So tangent is minus 4/3. So then going back tangent of 2 theta, we're just going to use this formula right here. Tangent of 2 theta is 2 times tangent of theta divided by 1 minus tangent squared of theta. So it's 2 times tangent of theta divided by 1 minus tangent squared of theta. So here you just have to do the algebra, okay? So this is 2 times minus 4/3 all over 1 minus 4/3 squared. Well, here the numerator is just minus 8/3 divided by, here this is 16/9, right? So this is 1 minus, because this minus is still here, but this negative here, when you square it, becomes a positive. So you just have to change the 1 here to 9 over 9. So this is minus 8/3 divided by, here, what do you get this? 9 minus 16, you get minus 7/9. So keep, change, flip. Negative, negative is going to be a positive. This 3 will make the 9 a 3. And you get 8 times 3 is 24 all over 7. So it was just going through the algebra there. There's a little bit of a pain, but we got it. All right, so just remember, whenever you have something like sine of 2 theta, sine of or cosine of 2 theta, or tangent of 2 theta, you can always use these formulas here to get rid of that 2 in there. Okay. All right, let's do some verifying trig identities here. All right. So let's verify this identity here, that in parentheses, sine of theta minus cosine of theta squared is equal to 1 minus 2 sine of theta. All right, so you have to pick a side to work with, right? And so, what I actually think you're going to want to do here is, wow, this side on the left looks a little bit harder. All right, so start with the left-hand side. And what you're going to want is you're going to want to simplify this somehow that I get a sine of 2 theta. Okay, so just note, just sine of 2 theta is equal to 2 times sine of theta times cosine of theta. So you're going to want to hopefully simplify this somehow that you're going to end up seeing a 2 times sine of theta cosine of theta. All right, so what you're going to do, you're going to rewrite this as sine of theta minus cosine of theta times sine of theta minus cosine of theta. And what you're going to have to do is you're going to have to FOIL this out. Okay? Sine of theta times sine of theta gets me sine squared of theta. Sine of theta times minus cosine theta is minus sine of theta cosine of theta. Minus cosine of theta times sine of theta is also another minus sine of theta cosine of theta. And minus cosine of theta times minus cosine of theta gets me plus cosine squared of theta. Well, look, check this out. Let me move this cosine over to the other side. So sine squared of theta plus cosine squared of theta. And then look, I have 2 of these. So minus 2 times sine of theta cosine of theta. And hopefully you see it, right? Sine squared of theta plus cosine squared of theta is equal to 1. And this right here, 2 sine of theta cosine of theta, that's just sine of 2 theta. So yeah, indeed, it just simplifies to be the same thing. So just trust the process, right? Like, go through, plug in your trig identity, see what you can do, or in this case, FOIL it out and see if you can simplify it to get the sides to match. All right, let's do another one here. All right, let's verify this one here. 1 minus tangent squared of x is equal to cosine of 2x. Is equal to, cosine of 2x divided by cosine squared of x. So I actually think I'm going to work with the right-hand side here. Okay, I'm going to work with the right-hand side here. All right, so let's start with this side. And so what I'm going to do here, okay, notice I have this cosine squared x in the bottom. So I'm going to substitute in cosine of 2x. I'm going to substitute in this cosine squared of theta minus sine squared of theta. Except here it's just in terms of x here. So this is 1 minus tangent squared x is equal to cosine squared x minus sine squared x all over cosine squared x. Well, look, what are you going to do here, right? I'm just going to break this up. I'm going to break this up into 2 fractions. And then watch what happens. Oh, gosh, look at this. Cosine squared x divided by cosine squared x, that's just 1. And then what's sine over cosine? That's tangent, but squared. So tangent squared x. Boom. We got it. So pick a side that looks more complicated, then give it a shot by plugging in an identity and see what happens. All right. Now let's talk about power reducing formulas here, okay? And what this does is this allows you to, basically take something like sine squared of theta and reduce the power so that it doesn't have a squared in it anymore. So here are the formulas. Sine squared of theta is equal to 1 minus cosine of 2 theta divided by 2. Cosine squared of theta, very similar, but it's equal to 1 plus cosine of 2 theta divided by 2. And tangent squared of theta is equal to 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta. Okay. So let's take this. All right, let's take, we'll start with, the sine here. You'll see. And so let's take this expression. So let's take sine to the 4th power of x. So sine sine of x to the 4th power basically here. And I want to write an equivalent statement that does not contain powers of trigonometric functions greater than 1. Okay. So sine 4 of x. Well, would you agree? All right, so I want to get this. Basically, I want to get this so there's no exponents other than 1. So sine to the 4th power of x is the same thing as sine squared of x times sine squared of x. Okay? Now look, I can power reduce. So whenever I see a sine squared, I can write in 1 minus cosine. In this case, it's going to be x instead of theta. Cosine 2x divided by 2. All right, so I'm going to have to do this for both of them, okay? All right, so now you can combine this, okay? This is 1 minus cosine of 2x times 1 minus cosine of 2x all over 4. All right, but what you have to do here is you have to FOIL this, okay? Because you're going to get another power here, right? So watch what happens when I FOIL this. You get 1 times 1 is 1. Minus cosine of 2x, and then minus another cosine of 2x gets me minus 2 cosine of 2x. And then look at this. Cosine of 2x minus cosine of 2x times minus cosine of 2x get me plus cosine squared of 2x. And this is all over 4. So look, I have a power greater than 1. So I've got to power reduce this cosine squared. But look, it looks weird, right? Because it's cosine of 2x. So like, here's the thing, okay? If you have, notice how this is theta here. If you have cosine squared of 2 theta, this would be equal to, so notice instead of theta here, I have 2 theta. This would be 1 plus cosine of 2 times 2 theta over 2. So it doesn't matter what, whatever you have in here, just multiply it by 2. That's what this formula is telling us. All right, so I'm going to plug that in now for the cosine squared, okay? All right, so I'm going to move this to I'm going to take this, I'm actually going to break it up so you can see it a little bit cleaner. So I'm going to break this up as 1/4 and so on, okay? So this is 1 over 4 minus 2 over 4, so that's 1/2. So minus 1/2 cosine of 2x plus, don't forget you have this 4 here, 1/4 times cosine squared of 2x. Okay, so I'm going to power reduce this. This is 1/4 minus 1/2 cosine of 2x plus 1/4. And then look, I showed you what that was. It's 1 plus cosine. Now 2 times 2 theta becomes 4 theta divided by 2. So 4x divided by 2. Now you just have to clean this up. So this is 1/4 minus 1/2 cosine 2x. So think about this. This is 1/4 times 1 over 2, so this gets me plus 1/8. 1/4 times this 2 down here, so plus 1/8 cosine of 4x. And then look, you just got to combine 1/4 and 1/8. So 1/4 is 2/8 plus 1/8. So this gets me 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x. Jeez. Whew. And now I have no exponents other than 1 here. So I did it. I fully power reduced it. All right, a little bit of a arduous process here, right? The formulas and using them in succession like that. All right, the next one here, I just want to quickly introduce you to half-angle formulas, okay? So it's sine of alpha divided by 2, all right? is equal to plus or minus the square root of 1 minus cosine alpha divided by 2. So notice how the sine of alpha divided by 2, all right, notice when I have the cosine of alpha, it's not the half angle. So the half angle is gone, okay? The divide by 2 is gone. Cosine of alpha divided by 2 is equal to plus or minus the square root of 1 plus cosine of alpha divided by 2. Tangent of alpha divided by 2 is equal to plus or minus the square root of 1 minus cosine of alpha divided by 1 plus cosine of alpha. Okay, so this is important. That plus minus symbol in each formula does not mean that there are two possible values for each function. No, instead the plus minus indicates that you must determine the sign of the trigonometric function, if it's positive or negative, based on the quadrant in which the half angle theta divided by 2 lies. Weird, okay. Let me just show you one quick example with these formulas. So basically with all these formulas here, and I know I've gone through this lecture pretty quickly, but with all these formulas here, just you should keep them handy in case you ever feel like you need to use them when it comes up in a problem. All right, so here's an example. All right, and I'm sorry, here are some other alternative forms of the half angles. So tangent of alpha divided by 2 is also equal to 1 minus cosine of alpha divided by sine of alpha, and tangent of alpha divided by 2 is equal to sine of alpha divided by 1 plus cosine of alpha. All right, sorry about that. So a little bit more of an extension here. All right, so let's use this. Use the fact that cosine of 210 degrees is equal to negative the square root of 3 over 2 to find the exact value of cosine of 105. Well, look, what is 210 divided by 2? It's 105. So look, cosine of 105 degrees is equal to cosine of 210 degrees divided by 2. All right, the reason we're going to care about this is when you have cosine of alpha divided by 2. So 110 is my alpha. Look. Boom. Right here. I can use this formula. Okay? But now I have to remember, is it going to be a plus or minus here? Okay? So it's 1 plus cosine of alpha divided by 2. Well, look. 105 is a quadrant 2 angle. We know cosine is negative in quadrant 2. So this is going to be negative. So it's going to be negative the square root, all right, of 1 plus cosine of 210 divided by 2. Okay, so why do we care about that? Well, look, I know what cosine of 210 is. Boom, it's right here. All right, it's negative square root of 3 over 2. So instead of plus, it's going to be minus the square root of 3 over 2 divided by 2. All right, so you just have to like clean this up, right? So I'm going to write 1 as 2 over 2. So now I can combine this. And then you're just going to keep change flip the interior, and this 2, 2 minus the square root of 3 divided by 2 divided by another 2 just ends up getting me 2 minus the square root of 3 over 4. And that right there is the exact value of cosine of 110. And it was just a little bit of a trick using this half angle formula. All right, class, I know this was a quick introduction here, very, very quick with just a few examples. But what's really, really important here is that you keep these formulas handy. Like if you have a cheat sheet of trigonometric formulas or trigonometric identities, like you put these formulas there, and that so when you see something, like going back here, like a sine squared of theta, I can power reduce it. Or if I see something like a sine of alpha divided by 2, I can get rid of the half angle here somehow. And you never know when these are going to come up. So just keep them handy. And then as always, if you have any questions, I'm here to help.